Good afternoon, everyone. Thanks for coming to our session. I know it's a bit late and the last session of the afternoon, so thank you very much for your patience here. My name is Roy, and we are a team. Our team name is Hard to Beat, and we are a team with 6 developers, 3 DevOps, and 1 BA. Our project's name is Virtual Queuing, and we came up with this idea of using a queue management system. Is actually a collective decision that we made. Initially, when we looked up, we feel like there are a lot more restaurants and international franchise now coming to the Australian market. And a lot of them still using the traditional ticketing or just simply call to manage their queue systems. So we found a market here and we're trying to produce something that will be able to solve this problem and maybe to help a little bit. And actually, the main features for this product is actually the CRUD operations to edit and create users and customers' information. We also incorporated SMS functions, so we are automatically just sending a message to a customer who has been introduced to the queue. We also can actively send a queue message to the customers to notice them what position are they in. We introduced a dashboard for the restaurants to be able to use it to distill any information that they can use to optimize their service. We created some charts and tables to help solve this problem. And finally, we have the queue separation for, like, if a restaurant has a branch, we can separate their branch queues to be able to just manage using one system to all branches. So these are the tech stack that we use. We didn't end up using a UI library, so we built everything from using style components. We use JWT for verification, MongoDB as a database, and Express.js for our backend. Twilio is the package that we use to send message, and we bundle everything up using Vite. Our testing library is Jest and React testing library, and we use frame of motion to improve a little bit of our animation. Hopefully, we want to just outsource our Twilio function to a Lambda, AWS Lambda in one point. At this stage, still not finished yet. And we use Git, Bitbucket, and Jira for version controls. So this is our timeline. We are today at the second demo, and we have completed version 1.0, 2.0. And what we're going to try to do next is basically just to improve the UI. And possibly there's an aspiration goal to include an interactive seat layout that you most likely see in like a cinema ticket booking system, where you can just click the table and just manage it from there. So now I'm going to pass it on to Ting to showcase, give us a little brief on the functions that we've done.
Thank you, Roy. Hello, everyone. This is Ting. Let me introduce some key features that our team has accomplished. As you can see on the sign up and sign in page, we've implemented JWT authentication to securely exchange the user information online. Once logged into the queue list page, please, the next page. Yeah. Once logged into the queue list page, we can start to change the customer status and to notify them. In this way, the queue list can be easily managed. Next page. By integrating Twilio with Node.js, we can send SMS messages to notify our customers by just one click. And when a manager user role logs in, so that's the next page, the data dashboard shows. And by analyzing and learning from the data here, we can help the customers to improve their waiting experience. Now Joe is going to demonstrate our queuing system for all you guys.
Okay, thank you, Tim. Share my screen. Well, now we are looking at the website of the virtual queuing. In this page, it shows a brief description of what virtual queuing is. And if we click the About Us button, we can see all the information of all the members. And we can go to the LinkedIn file and send an email by clicking these buttons. We can easily sign up a new account by enter all these emails and other details. For example, let me show you how to log in. Okay, after we log in, we can see the queue list page. On the left side, we can see the next customer info. And on the right side, there are all the informations of the queuing list customers. We can add guests here, or we can add guests easily by these two buttons. If we want to change the status of the customer, we can click the right button or click the absent button, and we can choose a reason why they're absent. And we can also send the notification message to the customer by this bell button. Okay. And if we want to search the specific customer, we can use the search area. And we can also shortlist or queuing list by click the queuing or absent. Now let's go to the dashboard part. In this page, we can see different charts that show in the performance of the business product. Business can understand their customers better from this dashboard and make better decisions. If we want to change the profile, we can go to the profile page and edit it. If we click the sign out button, we can safely exit our application. Our next step will be improve the user interface to provide better user experience and add more features such as seat layout and branch separation. Now, let's hand over to Roy for the rest. Okay.
Thanks, Joe. Okay, so this is us. We started with a team of 8, and there are 2 dropping out along the way, and the remaining 6 really came a long way until this point in time. We have been assigned. I must be honest. I feel like I'm really lucky and happy to be in this team. We tackle all the tasks that we get assigned to, and everyone was taking extreme ownership to their problem. And even like Elva, our business analyst, provide us with insights on data, what data is useful in our dashboard, and never be absent in any of our planning and retro meetings. And all our DevOps are really easily accessible and always quick and easy to deploy their techniques. So all in all, I'm feeling really happy to be in this team, and I'm really proud of it. So now I'm actually planning to switch over to Jesse, and we're going to plan on the next section of the DevOps introduction. Thanks, Jesse.
Thank you, Roy. Let me share my screen first. Good afternoon, everyone. Can you see my screen?
Yes.
All right, thank you. Okay. Good afternoon, everyone. My name is Jessie. I'm the DevOps.
先等等。
Yep.
右下角是可以打开幻灯片的。对。
Thank you. Let me start again. Good afternoon, everyone. My name is Jessie. I'm the DevOps in our team. I will introduce our architecture, CI/CD, IAC, and monitoring part of our project today. We implemented 3-tier architecture for the website. For our front end, we are using Route 53 to route traffic to CrowdFront. CrowdFront is used to accelerate content delivery to achieve low latency. We use S3 bucket to host our front-end static website, which store our code and assets. And we use ACM to issue SSL certificate to our CloudFront to keep our customer information private and secure. We also create S3 cross-region replication bucket because we want to save data in another region in case a disaster hits Sydney region. For our backend, we deploy to ECS Fargate. We have 3 Fargate containers in 3 availability zones. Load balancer can separate HTTPS request to 3 containers, and the containers can only accept traffic from load balancer to achieve high security because our backend is not exposed to public. However, our containers still need to send response back to our users, so we deploy a net gateway in the public subnet and connect it to 3 private subnets. Therefore, the routes can go from the container to net gateway to internet gateway and send back response to our customer. And the auto-scaling policy will also apply to our backend. Our desired task number is 2, and when the CPU utilization reaches 50%, a new container will be added automatically to match the increased load. Auto-scaling group is free, and we only pay for whatever resources are created underneath. Therefore, this is the more cost efficiency method. And for the database layer, we are using MongoDB, which is the NoSQL database program, and we plan to create multiple database backup in different regions for protect our data. Then let's talk about our CI/CD. We choose Jenkins as our CI/CD tool. For the front end, we install package, test the code, build artifacts, and copy the artifacts to S3 bucket. For backend, we use Dockerfile to Dockerize backend code and build the Docker image. Push the image to ECR, and Fargate can use the image to deploy our backend. Our AWS credentials and environment variables for our code are stored in Jenkins credentials and AWS parameter store to protect data leak. If you see the below picture, we have 2 environments. UAT environment pipelines would be triggered automatically when new code merged to main branch, while production environment pipelines would only be manually triggered when all the quality checks passed in the UAT environment. We also use Jenkins to run Terraform and deploy resources in AWS automatically. And we use AWS S3 bucket as our remote backend to keep our state file for our team members' use. The right side is our Terraform repo structure. Each component was written by module for future reuse. And in application folder, we are calling required modules, configure backend, provide variables, and write Jenkins file. For the monitoring part, we use CloudFront to collect required metric and use AWS Grafana to monitor performance of our website, including response time, availability, error rate, and saturation. We also configure an alert when running container is less than 2, which means our containers are not healthy and we should take some actions. For our logging part, we use OpenSearch to analyze VPC flow log to capture information about the IP traffic going from and going to network interface in our VPCs. That's all. Thank you so much.